Right now, 3.7 billion miles from where you're sitting, a dwarf planet the size of a small country is running an atmospheric process that has only ever happened in one other place we know of. Here, on Earth, 2.4 billion years ago, before there was oxygen in our air, before anything we would recognize as a modern living thing existed, that version of Earth, thick with nitrogen, soaked in hydrocarbon haze, chemically restless, has no surviving twin anywhere in the solar system, except one place. A place scientists spent decades writing off as a frozen, dead rock at the edge of everything. Pluto isn't dead. Pluto is running Earth's oldest program on a planet that never got the chance to finish what it started, and we only just found the proof. This isn't a story about a telescope taking a pretty picture. This is a story about a scientist who had what he himself called a crazy idea, got laughed off by the data for years, and just got proven completely right. What that proof might mean is bigger than Pluto itself. Let's start with the idea, because the idea came first, and the idea was strange enough that most of the field didn't take it seriously. In 2017, a planetary scientist named Xi Zhang at UC Santa Cruz looked at Pluto's atmosphere and proposed something that ran backwards from everything anyone expected. Every hazy atmosphere we'd studied up to that point, Saturn's moon Titan being the best example, works the same way. Haze particles absorb sunlight, and that absorbed energy warms the atmosphere around them. Warmer haze, warmer air. Simple, well understood. Observed in multiple places. Zhang looked at Pluto and said, "I don't think that's what's happening here. I think Pluto's haze is doing the opposite. I think it's absorbing energy, and then radiating it straight back out into space, faster than the thin atmosphere can hold on to it. Not warming the air, actively refrigerating it. At the time, there was no way to test this directly. Pluto is small, faint, and 4 billion miles away. You can't just point a backyard telescope at it and measure atmospheric heat balance in fine enough detail to catch a haze doing something no haze had ever been caught doing before." Zhang's idea sat there, cited occasionally, mostly unconfirmed, for the better part of a decade. Then, James Webb got involved. And it wasn't the pictures that mattered this time. It was an instrument most people have never heard of, MIRI, Webb's mid-infrared instrument. New Horizons, back in 2015, gave humanity its first close-up photographs of Pluto, the heart-shaped plain, the ice mountains, all of it, extraordinary. But it was one flyby, one pass. Whatever New Horizons didn't capture in those few hours, it was never going to capture, because the spacecraft is now 1 billion miles further out and still accelerating away. Webb doesn't fly past anything. It sits at a stable point roughly 1 million miles from Earth and stares, for as long as scientists need it to, at wavelengths no prior instrument could reach with this precision. In May 2023, Webb pointed MIRI at the Pluto-Charon system and captured something in the mid-infrared range 4.9 to 27 microns that had simply never been observed before. Not a photograph, a thermal fingerprint. The results, published in Nature Astronomy in June 2025 by a team led by Tanguy Bertrand, did something that almost never happens cleanly in science. They confirmed Zhang's crazy idea. In full, Pluto's haze really is cooling the atmosphere actively, continuously, radiating heat away into space faster than sunlight can replace it. And in the same batch of results, a second, independent prediction made years earlier by Zhang's then PhD student Linfeng Wan about how Charon's thermal brightness should vary as it rotates also matched the new data almost exactly. Two separate theoretical predictions, made years before Webb ever looked, both confirmed in the same dataset. That's not a lucky guess. That's a working model of physics nobody had ever directly observed before, now confirmed against reality. Here's why that matters more than it sounds like it should. Zhang didn't stop at "we were right about the cooling." He pointed at something much bigger. Pluto's atmosphere thin, nitrogen dominated, thick with hydrocarbon haze, is chemically very close to what Earth's atmosphere looked like before oxygen existed here. Before roughly 2.4 billion years ago, our own planet's air was a nitrogen and hydrocarbon mix. Not so different in basic character from what's sitting on top of Pluto right now. Earth outgrew that atmosphere. Life changed it. Oxygen took over. And the early chemistry got buried under 3 billion years of biology rewriting the sky. Pluto never had that push. It's still running the version of atmospheric chemistry that Earth abandoned before complex life ever got started. Which means, in a strange, very literal sense, there's a working model of very early Earth's atmosphere sitting 4 billion miles away, still running, still available to study, in real time, right now. That reframes everything. Pluto isn't a leftover, it's a control sample. Now here's where it gets stranger. Because the atmosphere isn't the only place this chemistry shows up, and the moon next door is where it's leaving fingerprints. Charon is Pluto's largest moon, about 750 miles across, locked so tightly in orbit with Pluto that the two of them don't really orbit each other so much as circle a shared point in the empty space between them. Charon has essentially no atmosphere of its own. What it has is a surface. And in October 2024, a team led by Silvia Protopapa at the Southwest Research Institute pointed Webb's near-infrared spectrograph at that surface and found two things that had eluded every previous mission, including new horizons: carbon dioxide and hydrogen peroxide, frozen, sitting there, in Charon's northern hemisphere. Hydrogen peroxide doesn't just appear. It's what you get when radiation solar ultraviolet light, cosmic rays, the slow bombardment every airless surface in the outer solar system endures constantly tears apart water ice molecules and lets the pieces recombine into something more reactive. Its presence is direct evidence that Charon's surface is still chemically active, still being reshaped by radiation. Right now, not just a fossil left over from formation 4.5 billion years ago. The carbon dioxide is a different kind of clue. Protopapa's team concluded it most likely originates from underground material from Charon's interior, exposed at the surface by impact events that punched through the crust and dredged up what was buried underneath. Every crater on Charon may be a small window into material that's otherwise sealed away. And then, more recently, a separate analysis found something even harder to explain cleanly: methane, escaping from underneath Charon's water ice and carbon dioxide surface. In amounts nobody predicted, not methane drifting in from somewhere else. Methane apparently sourced from below, working its way up and out through a crust that was supposed to be geologically settled and quiet, outgassing on a body that isn't supposed to have any internal engine left to power it. The honest answer right now is that nobody fully knows where the heat or the process driving that comes from. It's an open case file, not a solved one. Put those three findings next to each other. The atmosphere cooling itself in a way no other hazy world does. The early Earth chemistry sitting exposed and observable for the first time. And a moon that's supposed to be inert, quietly leaking gas from somewhere underneath its own crust. You start to see why researchers keep using words like unique and unexplained about a system most people wrote off as boring the moment it got voted out of the Planet Club in 2006. Try to picture what any of this would actually look like if you were standing there. The sun, from Pluto's distance, isn't a disk anymore. It's a hard, brilliant point of light smaller than a pinhead held at arm's length, roughly 1,000 times dimmer than the sun you know. You could look straight at it, and it wouldn't hurt your eyes. It wouldn't warm your skin at all. The sky around it wouldn't be black the way you'd expect deep space to be. Pluto's atmosphere, thin as it is thick enough with that self-cooling haze to wrap the horizon in layers of blue-gray twilight that never fully lift and never fully darken. No sunrise, no sunset, just a permanent, dim, hazy dusk 4 billion miles from anything warm. And overhead, not moving, because Pluto and Charon are locked in that shared orbital dance. Charon would sit fixed in the exact same spot in the sky, day after day. A pale gray companion that never rises and never sets, just hangs there, while unseen gas quietly leaks out from underneath its surface. Invisible, constant, still not fully explained. That is the system Webb has been quietly staring at for the past 3 years. Not a flyby, not a single dramatic photograph. A patient accumulation of thermal readings and spectral fingerprints, each one confirming or complicating a theory that started as one scientist's rejected hunch in 2017. And this is bigger than just one dwarf planet at the edge of the solar system. Because Zhang made a point of saying so directly, the physics behind Pluto's self-cooling haze isn't unique to Pluto. Neptune's largest moon, Triton, and Saturn's moon, Titan, both have nitrogen and hydrocarbon atmospheres full of haze particles built from broadly the same chemistry. If Pluto's haze behaves this way, the working assumption is that we may need to re-examine how haze behaves on Titan and Triton too, worlds we thought we already understood reasonably well. One confirmed crazy idea on one small, formerly demoted world just opened a question mark over multiple other atmospheres in the outer solar system. So here's where that leaves us. A model of Earth's oldest atmosphere, still running, 4 billion miles away, a moon next door, leaking gas from underneath a surface that was supposed to be finished changing eons ago, and a physical process haze that cools instead of warms that may not be a Pluto oddity at all. But our rule scientists are only now realizing they need to go back and check everywhere else it might apply. Pluto lost its vote in 2006. Nobody's arguing about planetary status anymore. The real argument researchers are having now is a much stranger one. How much of the solar system's oldest chemistry is still quietly running, unfinished, in places we already stopped paying attention to. Thanks for watching, and I'll see you in the next one.